to this PTR podcast discussing EV batteries in the current global market. My name is Abdullah Kamran, and I am the analyst for energy storage at PTR, and I will be your host today. To delve into the topic further, I have my colleague Fatimah Zahid with me, who is currently working as a senior analyst at PTR in the e-mobility domain for the past 2 years and is also the subject matter expert for the Asia Pacific region. Along with me, we have two guests, special guests from Minespider. Minespider is a platform that enables a collaborative supplier network and provides tools for the future of sustainable EVs, such as the battery passport, that is designed specifically to capture and communicate key sustainable supply chain data. We have Anastasia and Pavlina with us today. Both guests are battery supply chain experts at Minespider, a blockchain technology platform for supply chain optimization and traceability. Perhaps you could start me by giving me a little intro for each of you and your expertise. Pavlina, could you start, please?
Of course. First of all, thank you, Abdullah and the PTR team for having us as guests on this very interesting topic, and we look forward to the discussion. So I come from a background in the 3TG mineral space, where I worked on implementation or actually supply chain due diligence and compliance for conflict minerals. And at Minespider, I'm the project leads for implementation of battery traceability projects. So as you already mentioned, we are one of the leading traceability platforms, and basically my day-to-day here is around the implementation of traceability with companies from the battery supply chain, as well as the implementation of the battery passport solution within our EU Commission funded project called BETRO, where we work along with a few other companies as part of a consortium, and implementation on the same solution with some of our OEM partners. So yeah, it's a real pleasure to be here, and I would pass the floor to my colleague Anastasia so she can give a bit of an introduction for herself too. Thank you.
Thank you, Pavlina. So my previous background is all about communication, marketing communication, and research for technology companies. And at Minespider, I am focusing mostly on research of the EV market and battery supply chain. And this is a pleasure for me to be here, and thank you for your kind invitation.
Thank you for introducing yourselves. So before we begin things off, I would like to take out a moment to mention and thank our sponsor for this podcast, Power Systems Technology. Power Systems Technology is the new sister brand of Transformer Technology that aims to be the digital voice of the power industry. To dive into the topic of today's discussion, which revolves around the ever-growing EV battery market, going over the current landscape with regards to demand and supply, the problems that the current market faces, including but not limited to bottlenecks created by supply chain problems and regulatory issues that act as barriers for market growth. The EV market has seen massive growth in the past decade. Most countries now have emissions reductions targets in place. This has led to the EV market seeing exponential increases in demand and supply. As a key component of EVs, the EV battery market has also been affected by the substantial growth in demand. The current PTR oversight estimates more than 250 million EVs to be active globally by 2030. To cater to this increasing demand of EVs, projects catering to the production side of EV batteries have also witnessed a boost. Over 100 gigawatt scale battery factories around the globe are set to be installed in the near future to help remove any possible production bottlenecks the industry could face. With that in place, I would like to start off the discussion today with a question to Anastasia. As there has been substantial growth in the EV battery industry, what are some of the most successful developments in the field of EV battery market in terms of market regulation, and which countries are leading this development?
Thank you for your question, and let me start from the second part of it. So who are the market leaders? This is for sure China, and China accounted for 3.3 million EV sold in 2021. The second is the European Union with 2.3 million, and the third is the US. This is obvious that market will continue to grow, and this will create a significant demand for lithium-ion batteries. It will also stipulate the regulation development. And I should say that EV and battery market regulation is a complex issue, as it should correlate with the raw materials policies, with sustainable production principles, and with countries' environmental and energy policies, including carbon emission goals. So this is quite a complex subject, as I told before. And besides, the battery supply chain is diverse and complex too. So many materials are coming from different regions. And for example, lithium can either come from South America, Argentina, or Chile, while graphite can be produced only in China, for example, predominantly in China. But still, there are very successful developments in terms of regulation. And let me start with the European Union. The European proposal on batteries from 2020 is a huge step towards clean energy and circular economy. It sets certain requirements to all battery supply chain participants, and they should have specific share of recycled content for critical minerals, such as lithium, cobalt, nickel, and lead, calculating carbon emissions, and also complying with some due diligence requirements. The European Union battery regulation will require battery supply chain participants to have a battery passport. And the battery passport is a digital copy of the battery that contains all the required information. I should also say some words about China, because China has been very productive in terms of the battery regulation and EV market regulation. One of the most important Chinese regulation in this regard is 14th five-year plan, as it defines strategic emerging industries, and new energy vehicles is one of the priorities. There are also some specific regional regulations that are focusing on integrating new electric vehicles production. China has also extensive policy on recycling, and it requires electric vehicles manufacturers to set up special standardized recycling plans. And China also provides some tax incentives to the new electric vehicles producers. The last but not the least is the United States with the Inflation Reduction Act, which was introduced in August this year. It will provide certain tax credits for the EV buyers up to $7,500. Not all electric vehicles producers can get these tax credits. They should meet certain criteria for value, type, battery materials, and component requirements. So as you can see, this is really hard. This is a really hard and complex area. However, we do have some really successful developments in terms of regulation.
Thank you, Anastasia, for providing such a comprehensive statistical overview of the market in terms of demand and growth, and a very keen point on the effect regulations and plans have on this industry. I would now like to ask Fatima on her take for the regulatory aspect of this discussion. So are EV manufacturers also aligning their practices to EU regulations? And what is the importance of developing partnerships with recycling companies to create a circular economy to improve sustainability?
Right. Thank you so much, Abdullah. That's a great question. And like Anastasia rightly pointed out, there are a lot of countries that are highly incentivizing the recycling of batteries. But I'd like to raise a point of how the repercussions are building throughout. Now, with 2020, between 2020 and 2021, we've seen EV sales boom. So they've increased by 50% to about 6.6 million this year. And by 2030, we're predicting, so PTR is predicting that your EVs could exceed 50% of the total automotive sales that you have. So now, in order to electrify your mobility sector, it is important that your batteries need to be recollected, they need to be treated, reused, and recycled effectively. And by 2030, we're forecasting that more than 1 million batteries will have to go through this process in Europe alone. Now, your recycling materials will cut the cost of the battery by 4, so it will reduce the carbon footprint by 40%. And at the same time, it will also address the bulk of the EV's life cycle footprint. So this will have an enormous impact on the EV vehicles, as half of the production of the emissions are embedded actually in the battery. So in order to drive down the cost of electric vehicles, I think it is imperative that we reduce the material cost. And that can only be done by localization and the use of recycled content. Now in EU, there are a lot of regulations that are specifically targeting recycling batteries. And these new batteries should contain a minimum amount of recycled raw material in it to maintain the circular economy of those batteries. While we look at North America, there are a lot of EV battery manufacturers that are partnering with your recycling companies. So Redwood is a company that is directly working with Volkswagen. And what they're trying to do is they're trying to recover more than 95% of your metal, like nickel, cobalt, lithium, and copper from the batteries. And then rather than exporting those metals overseas, they're using them to remanufacture their anode and cathode components that can be supplied back to the US battery manufacturers without these minerals ever leaving the country. Another important development that I'd like to highlight is that the automaker also has a joint venture with LG Energy Solutions. So they've opened their first battery cell plant in Ohio that is going to recycle up to 100% of your battery cell scrap that is there within the plant. So definitely there are a lot of EU regulations that are in place, and in the future we would also be seeing more partnerships like these in Europe. And battery passports are definitely going to play a pivotal role, as they're supposed to include the amount of your recycled material that were used in the battery. So yeah, that's how it's going to go about.
Yeah. So, okay. So as Fatima mentioned, some challenges that the industry could possibly run into, it is fair to have visibility on other such issues that might affect the industry. What are the major challenges related to the current EU battery regulations? Maybe some areas that the regulations do not cover currently, such as the tracking and calculation of subsequent carbon footprints. Pavlina, what are your thoughts regarding this?
So yeah, just to build on what was said so far, to give a bit of a background, just a few days ago, actually on the 9th of December, the EU Parliament and the Council had reached actually a provisional political agreement on the draft text for the EU battery proposal. And this is making it one of the most extensive regulation in terms of the scope it has, because it will cover the whole life cycle of a battery. So what this means actually is that it is a key achievement under the so much mentioned European Green Deal, and a way to make batteries more sustainable and ultimately create a new way of functioning that includes responsibility and a lot of social and environmental aspects. This not only cover the way of how the battery is manufactured, but actually the whole process, starting from the very upstream companies, thinking of the raw materials, the consumption, and the end of life through the reusage and recycling phases. So, for example, when we are speaking about electric vehicles specifically, the main requirements come in three categories. So we have a lot of accent on the stronger sustainability, performance, and labeling requirements, a special section on the due diligence parts that will actually affect the social and environmental risks, and the targets that Fatima mentioned on recycling, waste collection, and material recovery, as well as the implementation of the battery passport. Now, these are a lot of requirements, and we have a complex supply chain here. So we can group mostly the challenges in three categories. First of all, it will be the standards of how all these details would be calculated or presented. Then it comes to structuring these data sets and how they will be put or shared within the battery passport or the electronic exchange system, and then the actual implementation process. So, for example, when we speak about safety and sustainability requirements, if we take the carbon footprint details, the regulation states three ways of how the carbon footprint should be presented. It starts with a declaration, then we have the classes and the thresholds. And even though there is a list of, let's say, indication to the main methodology, however, this implementing act that should present the exact way of how the carbon footprint values should be calculated is yet to be announced. So this is one of the challenges, like companies can start one way, but the act may be a bit adjusted in the course of the coming period. The same for the recycled content and the targets. There are certain targets, but so far industry thinks that they might be a bit ambitious. And the methodology on how this will be calculated would need to be basically built as a collaboration method between the government institutions and the actual industry players. So as it's a very complex supply chain, what we suggest and what we see as a best approach is these companies which are directly affected, especially by the battery passport, like economic operators placing the batteries on the market, should start analyzing their supply chains, see who it is in up to the very upstream level, and take a bit more of a proactive approach to identify any gaps and challenges and find a way to adjust their system so that they can timely react to any requirements once the regulation is adopted. So yes, that should be one of the ways how things should move, and it comes with a set of challenges, but it is doable and it is a very encouraging regulation.
I completely agree with your point. Transparency and structure are the best way to ensure that the process is optimized and smooth flowing. Talking a bit about the supply chain issues which have been previously known to cause bottlenecks in the industry, Fatima, could you elaborate on some of these impediments and the impact they have had on the EV manufacturing industry?
Definitely. So your EV battery supply chain, it faces a number of obstacles, and one of them is the high cost and the environmental concerns that are associated with the extraction and processing of your key metals. And today's low prices, which reflect an overestimation of your short-term demand, it will eventually hurt the investment in the future for the exploration and production projects. And we could be witnessing the beginning of a structural undersupply of your key battery metals, which will have a significant impact on your EV manufacturing. Now, take the instance of your cobalt mining. Now, cobalt mining is concentrated in one country, and that's Congo, which is responsible for 65% of the global supply. And it's also one of the least developed countries, and it has very limited transparency in the cobalt value chain. Lithium, on the other hand, does not face mining shortages, but your rising prices of the core battery material has caused lithium rush in countries like Australia, Chile, and Argentina. And however, a global increase in the demands of EVs due to your weak automotive market and a reduction in sales in countries like China, they have resulted in a slower pace in mining and also your plant construction. Another major impact was the global pandemic. So your pandemic created a lot of uncertainties to the sustainability of your existing supply chain. And many manufacturers, especially EV manufacturers, were reluctant to invest in the industry even before the outbreak because of the economic tensions between US and China. And so your businesses might lose future profits due to the single point of failures in the supply chain, as seen with Audi and Jaguar and Land Rover. Another interesting point that I'd like to make is China is one of the largest buyer of EVs. That's an established point, but it also is the producer of the bulk of world's lithium. Last year alone, they produced 79% of the lithium hydroxide that's used in your electric battery cars. And the prices of lithium hydroxide has rose by 3.1% last month, and this was the first increase since May 2019. So your Chinese producers are actually explaining this sharp increase by higher production costs and the logistic difficulties that were caused by COVID-19. And your major battery players like CATL and BYD, they had to delay their productions because of the shortage of labor, raw material, as the government was fighting the virus.
Okay, Fatma, that's interesting. So what new approaches are being taken by EV manufacturers to counter the impact of delays on the supply chain of EV batteries?
Yeah, that's a very interesting question. Now, we see that the EVs sales are going to explode in the years to come. So manufacturers ideally need to find a way to either ensure a continuous supply of cobalt and lithium or find viable alternatives. And to compensate for that, recently your EV giant Tesla agreed to buy lithium phosphate batteries, which is a principal alternative to your cobalt containing batteries for their Model 3 cars in China. So while this move is a clear signal for the global battery market, its impact may be questionable as the decision would apply to Tesla's shorter range models. And it would also counter the China's dominance in the lithium market. So I think to conclude the answer, I'd like to say that in the long term, both car manufacturers and governments in specific need to adapt in the long term to sustain the battery components in order to electrify your transition. And this would require consistent R&D to explore new storage technologies, as well as policies that secure the upstream, midstream, as well as your downstream flow of critical resources. Governments in Europe and US already have taken bold initiatives to develop a very domestic battery supply chain, as I highlighted in earlier. And so I staunchly believe that your governments must leverage private investments in sustainable mining and also ensure that there's a rapid permitting procedure to, avoid the potential bottlenecks.
Okay, so what I take from that is that the introduction of alternate technologies and favorable policies can mitigate the effects of current supply chain issues and pave the way for a globally stable market. So Fatma, let's just digress into the electric vehicles market for a bit. There must be some innovative technologies being looked at for this industry too. I'm very intrigued to know what some of those innovations are and what we would need to look out for in this market for the future.
Definitely. So there are new investments in the EV charging infrastructure globally. There's continuous improvement in the vehicle range, and then there are new models of EVs that are spurring this growth. But there's also a dire need to make the EV charging ecosystem very reliable, safe, and as well as cost effective. So one of the new emerging trends that I'd like to highlight is the self-healing algorithms. So they basically entail building, so they're actually built into an EV charging management platform that can fix up to 80% of your software-related operational issues that render EV chargers unusable by drivers. So what it does is that you have your real-time issue discovery, and then that automates the self repair that maximizes your charges uptime and also optimizes the entire EV charging experience. Another trend that I'd like to talk about is your V2G charging. Now, your V2G charging is basically, it envisions using smart EV charging to control the two-way flow of your energy between your EVs and your grid. So instead of generating more power during the peak times, your utilities basically purchase that stored energy from the EV owners and then distribute it to the grid. And then during your non-peak hours, the EVs could obviously draw that energy for recharging. So it essentially allows you to, allow the flow of energy in both the directions, and it balances out the variation in your energy production as well as consumption. Currently, you have a lot of V2G pilot projects that are running across Europe as well as US. Recently, there's a company called Indra that's based in UK. They developed their first domestic V2G charger. And they've, I think, so far manufactured thousands of those chargers because they've gone through their beta trials. And then, so when you talk about vehicles, your vehicle also needs to be compatible with V2G. And Nissan Leaf is one of those cars that is V2G compatible. And they also recently partnered with Fermenta Energy, where they built a charger called FE15, which is a bi-directional charger that basically allows you to send energy back to the grid. So I think that this V2G technology is definitely a very ubiquitous trend that we need to look out for in the future. Lastly, one thing that I'd like to raise is the concept of megawatt charging system. So this new solution is basically for your high power charging for your heavy duty vehicles that you have. Now, what this entails is that it's basically designed for your DC charging, and it can go up to 3,750 kilowatt. So your trucks can easily add about 200 miles range within half an hour of your charging session. So the goal for this megawatt charging system is that they're making a universally accepted charging connection for your large and medium commercial vehicles, whether they're on land, water, or even in air. So a recent project that a pilot project that was run on megawatt charging system was run by Daimler Trucks in North America and Portland General Electrics. So they basically set up an entire area for the installation for those megawatt charging system chargers, as well as a battery storage unit. So yeah, so these were probably the trends that you need to look out for, and they're definitely going to transform your EV charging ecosystem as well as the entire experience of charging.
Thank you for this, Fatma. So your informative comments show that extensive research and development is being carried out in the EV industry, and hence the market shows great promise of continuing the growth that we have seen over the past few years. But looking back at the conversation, it is evident to me that regulations play a major role in driving the market. Pavlina, I would like to ask you about the due diligence requirements for such regulations. For example, for the EU battery pack, do ESG and supply chain sustainability requirements evolve and strengthen the regulations that are then published?
So yes, due diligence comes as a crucial part of the EU battery regulation proposal. In fact, there is a separate chapter dedicated to these specific requirements. So the idea here is that economic operators placing the batteries on the market would have to implement or fulfill certain requirements in order to show they are taking into account responsible sourcing practices and they are aware who is in their supply chain. So the overall idea is that over time, with these requirements, companies would be able to benchmark their suppliers. So for example, a downstream OEM would be able to know through this system or rankings in a way how certain suppliers perform on the ESG front. Or customers would be able to see how companies are performing so that they can make a decision from which supplier or from which manufacturer to buy a vehicle, for example. When we are speaking specifically about the battery passport and the due diligence requirements, it's important to note here that the main requirement is for a supply chain due diligence policy to be part of this battery passport. However, this goes hand in hand in combination with the auditing component. What this means is like the battery producers or a company placing batteries on the market, they would need to have this supply chain due diligence policy, but it needs to be audited either by a notified body or a third-party auditor. And this report should be part of the actual battery passport. So in order to actually create this policy and report, companies in the background need to have internal systems for chain of custody or traceability. So a special part of the regulation indicates to how this system should be built out and what information it should contain, so that it can cover the risk parts on the ESG and also connect to some of the international regulation when it comes to the ESG parts, such as the OECD guidance on due diligence, for example. And one of the ways how this can be addressed is by using technologies and platforms, for example, like the Minespider solution, to build the traceability systems and this chain of custody from the very upstream points. So, for example, some of the points that companies need to be aware from their upstream suppliers is when it comes to raw materials, they would need to state where the actual raw material provider is located, what is his company name, what is the exact type of raw material, the grade, and even the percentage of that specific raw material within the battery they are placing on the market. So the end goal is basically to make all producers aware of how the material moves along their supply chain, how it's transformed, and how it ends with the battery, with the end goal to make sustainability and circularity of the supply chain much more feasible in a way that it covers the raw material scarcity challenges in a way that we can also use recycled materials with the end goal of basically having more informed decisions once batteries reach end of life. So yeah, what it means is basically we're at a point now where with all the raw materials contracts in between OEMs and very upstream players, we see this is a very important part, and the only way of how you can get knowledgeable is by basically mapping the supply chain and implementing chain of custody or traceability systems in place that are in line with all these requirements and international regulations covering the ESG aspects mentioned in the regulation.
Thank you for your answer, Pavlina. So, to cap today's discussion off, it can be said that there's no doubt that substantial growth can be forecasted for the EV and EV battery industry in the coming years, which will no doubt aid the ongoing EV revolution for years to come. Today's conversation has been very enlightening for me, and I, for one, am excited to see where this growth takes the world. So, Anastasia, Pavlina, Fatma, thank you for joining me today to share your valuable insights from your experience working in the EV and EV battery industry to help us get a glimpse of what can be expected for the future.
Thank you very much.
Thank you so
Thank
much.
you.
Thank you.
It was my pleasure to have you all on the podcast, and thank you to everyone tuning in for being with us on this journey. And I would like to end today's discussion with that. You can catch this episode of the podcast and all previous podcasts on our website, Apple Podcasts, Google Podcasts, Spotify, and YouTube. I have been your host, Abdullah Kamran, signing off. Until next time.